In this video, we're going to look at an HTML file with JavaScript that is going to read a CSV file with some data. In this case, it's Kepler's law data, the names of the planets, their periods, and their distances from the sun. And then first, we're going to put it in a GridJS data table. And then we're going to allow the user to pick two quantities, presumably numeric, so not the planet, but let's choose as the x the distance and as the y the period, and then use a Google chart. And in particular, we are fitting the data to a power law, which is not, as far as I can tell, one of the provided fits. They have linear and exponential and polynomial, but I have not seen that they have power law. So we have included in this code is the what's necessary to fit data to a power law. Okay, so if you want this code, it's at the URL seen here. And let's get started. So I have a link, a CDN to the GridJS, to the code, and to the styling. And I also have a link to gstatic, and that is for the Google charts. So there are my connections to my CDNs. Okay. The style, I don't have much style, as you can tell, but this styling is for the overlap, so I can display the equation. So this here is, we're going to call it, Google chart seems to call it an overlap, and we are going to have this overlap displaying our fit equation. And that's mainly what this is about. So there'll be, as we'll see soon in the HTML, there'll be a div which contains sort of an overall container. And then we will have a container for the chart and a container for the overlay. And this is their styling. Okay. So I had just an overall header, a header for the grid, a div for the GridJS, and then that gets populated after I fetched my data. I prompt the user to use my drop-down selects. So I'm going to pick from the set of possibilities an X and a Y, where the user's going to do that. And then here is a button for, of course, we're fetching a file, so we can't sort of jump ahead and just automatically plot the file until we have data. So, and the user needs to pick what they want. So the action is then on a button. So that's the button that we'll call the plotting action. And then finally, here's the section for the Google chart. And then here's that the HTML corresponding to the style we saw above, this overall container for the chart, the actual chart, and then the overlay of the chart. So two divs inside a larger div. Okay. I have two arrays here for the data and what GridJS tends to call the columns, and I'll often refer to as the headers. And so scroll up. So here are the headers, planet, period, distance, and then the data. And so I'm going to read in a CSV file. That CSV file, if you want that data, can be found at this URL, but I'm reading it locally. And so I'm doing a fetch. I'm sending back the text of what I fetched. And I am start to call that file data because there are just too many things called data. GridJS tends to call what you're making data, and Google Charts tends to call the data. And it's sort of standard when you fetch something to call the data of the file data. but there were just getting to be too many things called data, so I made this file data. And it is a CSV, as we said, so we are first parsing it on escape or escapes the return sequence and the new line sequence. So we're breaking it up based on lines, and there was a little trim in case sometimes the end of the file there may be a blank line or there may not be a blank line, and that can sort of throw things off. So we're trimming to deal with any issues there. And parsing on this return and new line, and using a map. So we're looping over the lines that we got from parsing it on a line. And then I am parsing each line. In each iteration of this loop, I'm parsing a line on a comma. It is comma separated variable, CSV. So a comma is the delimiter. And I get an array called tokens from my split. And the first one I also have a counter in my map. So when I'm on my first line, then that's what I'm calling the headers, but GridJS tends to call columns. And so that first, when I was 0, I took my tokens and put them into the grid columns. And for everything else, I put it into the data. So now I'm ready. Now I have the format that GridJS wants. And so here is me invoking the GridJS grid. In many of the examples you find on their page, it just says grid, but I found I needed GridJS.grid. That might be because I'm using the CDN. They want the data and the columns, and I said it was sortable. And there are other things you could do here. Pagination has a lot of, GridJS has a lot of nice data table features, but there were only 9, so I didn't go for any pagination, but I could have. And I didn't do any searching. I just did sort. Okay. And now I also wanted to, now that I've read the data, I read the data and put it in the format for GridJS, and it made this data table for me. I also know what the user can choose for the plotting. So I'm loading up my drop-down select. So that's what I have next. My X select, my Y select, looping through the columns or the headers, and loading up, generating options and adding them to the selects. So now the selects have planet, period, distance, the headers. And so now I'm done reading my file and I'm ready for my user to interact. So far it was sort of system things, the file being read and then generating the JS, but now we're ready to interact with the user. The user selects the data. We have no, we're presuming that they have selected the data, but there is no event function handling of that, but there is an event for the clicking of the plot function. So we add to the button an event listener for when you click the button called plot data, and then here's that function. And I need to know what the user wants to plot. So I get from the selects the X and Y header to know what they want. And now I want the actual data corresponding to those headers. So I'm using a map here, and I'm selecting out the column that they want. So I have a map, which is sort of like I loop through an array and grab things, and GridJS data is really sort of an array of arrays. And so on the sort of outer array, I have this map, and then I have this function, and I am grabbing a particular column, whatever the user chose to be the X. So I'll be looking in the grid columns, the headers, and so searching for the header they fixed and using index of. And then I'm going to the data array and grabbing the value of that array with the same index. So value was the sort of the inner array, and I am grabbing just the value with that index that matches the header index. So I'm grabbing the X data, and then I'm grabbing all the Y data. Okay. And now, again, I like Kepler as one of my standard examples, and it is a power law, and I did not see anywhere where Google Chrome had that, where Google Charts had that kind of fitting. So I give just a little quick primer on fitting to a power law. The form we're fitting to is y equals ax raised to the b. Standard approach is to take the log of both sides, so log of y, standard thing with logs, product split, and powers multiply. So log of y equals log of a plus b log of x. And now that data, after you've taken the log of the y data and the log of the x data, you fit that to a straight line by standard techniques. And then when you get the constant for that, the constant will be log of a. And so then if you want a, it's the exponential of a constant. And the slope, which we see as b above, is the power of the original power law. So now we're ready. So the first thing I'm doing, again, lots of map here because I'm working with arrays, and it's a nice, convenient way to get everything done to all the elements of an array. And so we're getting log x and log y by mapping onto the log function from the math library. And you can see I was console logging out right and left to make sure I was doing what I thought I was doing. Here is the sort of defining a function using reduce to get the average. So we are looping, starting the sum at 0, adding the current value to the sum. So we're going through an array, and then we're adding them all up and then dividing by the length of the array. And I'm working again with the log of x and log of y. So I got the average of log x and the average of log y. And then from there, I want all of this best fitting stuff uses the deviations. So in the deviation, each point is the deviation is the difference between it and the mean. So again, another map where I'm getting the log x deviations. So I'm subtracting off the x average or the log x average and the log y average. Okay. And I'm using language a little roughly there, but okay. So now I have had the x data. I took the logs of it. I found the average of that. Now I have the deviations. I have another reduce in here that defines a dot product. So I have two arrays, and the dot product is the first element of A times the first element of B plus the second element of A times the second element of B, add that all up. And so we see here we're multiplying A, and so first there's a map, and I'm multiplying A and B, and then I do a reduce to get to the sum of those things, and that is the dot product. And I want the dot product of log x deviation with itself, log y deviation with itself, and log x deviation with log y deviation. And this is standard approach to get the sort of least square fit. And the power, or the slope, if you will, if it were, again, the slope corresponds to the power of the original, and that is the xy over the x squared. So that has units of y over x, and so it has the units of slope if we were talking about a normal line, but here we're talking about a power. And that gives you, so that's how we get the power. And then we can take the y minus the power times the log of x. That gives you in standard, that gives you the constant. And then the coefficient is the exponential of that. So I put all that together. And so there is my power, the two parameters of my power law fit. And now I'm ready to make my chart with the original data and that fit. Okay, so now I got to put the data into the format that Google chart data wants. And whereas GridJS separated the headers, scrolling, GridJS wanted headers and columns separated. Google Charts wants them more combined, and it's just the first entry is the headers. And so it's going to be an array of arrays, but the headers, the first entry is going to be the headers. So I start off with and my overall array Google chart data, and then I'm making an empty array for an entry, and I'm making it the X header, the Y header, and I'm just saying the word fit. And I'm pushing that. So that is the first array. So it's an array of arrays, and this is the first array that we push on, and that's the array of headers. And then I'm going to start on the data, but the data is going to come in two sections. I have the data of the original data, and then I have the data for my fit. So right now I am looping over my X data, and I am making a blank entry, sort of clearing out my whatever I had before in terms of an entry. And the first entry is my X, and the second entry is my Y. I'm parse floating them because when I parsed the data, it was treated as a string. So it comes in as a string. And Google Charts needed it to be numbers. So I needed the parse float to make sure it was a number. So it was something like the plot. And then my third, so I have three columns, the X, the Y, and the fit Y. And right now I'm working with the data. So the fit Y is null. So I'm making all these entries that are the data, and for that, the fit is null. But I make my array with 3 elements and push it on to the array. And if the user accidentally chose the names field, which was not numeric, then we should see this alert. Okay, now also another loop to add up, and this time the fit. So I have this loop over going from the lowest value, which was 0, to the highest value and going up by ones. That should probably be improved, but again, an empty entry, the X value, the second entry, entry 1 here is the null, so there's no data because we're doing the fit, and then the entry with an index of 2 is the fit, and that's the coefficient, and then again, we're using the math library, math pow of the X raised to the power. And so that created, now I have all of my data in the right form for a Google chart. The first one is the very first entry is the headers, then comes the data. And when I'm doing the actual data, the fit is null. When I'm doing the fit, the data is null. And now I'm ready to make the chart. So this is the standard thing for making a Google chart. And then the interesting part, so most of this is just sort of standard copy, and a little more interesting comes in the options. So I decided to have a title, and throw in what the user chose for the Y and X header. When you talk about verses, it's usually most people say the Y versus the X. So I put those in, this crosshair allows you, like, oh, I commented out the legend. If the legend, if we were doing one of their standard fits, then we'd have less work to do, and the legend would be where you would see the equation of the fit. So for other things, you would want the legend. But for here, since we're doing our own fit, I've commented out the legend. The crosshair is a user interaction thing. When the user sort of gets onto a point, then you get these crosshairs and then tell you the actual X and Y of the point. So that was the crosshair thing. Series is using it to distinguish between the data points. So here these are the Y's. So this is the 0th Y, but up above it was the index 1, but now it's index 0 because we don't count the X, because they're XY points. So the first one, and that was the data, was a circle, and I gave it a point size of 20, so that's quite large. That's these very large blue dots, and there are a bunch of all the beginning planets are very close together down here. So that's sort of 3 or 4 blobs down there. Okay, and then I used little triangles of a smaller size for my fit equation. I've labeled the H axis, the horizontal axis, with the X header, and the vertical axis with the Y header. So that's this. Here is the X distance, and here's the Y period. And then this is the standard make a chart thing. This part changes because I'm putting it on my page, so I need an element with an ID that's on my page. But otherwise, it's sort of standard Google chart stuff. And again, the CDN is up in the head that allows me to do all of this stuff. And then finally, I wanted to display my fit equation, and I'm using that chart overlay thing for that. So the chart overlay has sort of always been there, but it's been empty. And now I'm putting something in there. So I'm putting in the equation using template literals with this tick mark, and Y equals, and I'm putting in my coefficient, which I've rounded to 4 places. X, I'm using the SUP, to raise it, to raise what's between SUP and close SUP up. Superscript. So, and then I'm making the power. So I have Y equals some number, X raised to some other number, which we saw with 4 decimal places. And we're at the bottom of the script. So that's what I wanted to show you in this one, just sort of a little hodgepodge of things. A Google chart with a power law fit, which they don't supply, so we needed to supply a lot of stuff. And also the GridJS table that we used to start and sort of display things for the user, so then the user could decide what they wanted to plot. So that's it. Thanks for your attention.